Uh, so adding two polynomials, um, we can do it just by adding their coefficients. Suppose that you have two polynomials with same degree. Even it's not the same degree, x plus e0 and q of x. These are polynomials with one variable, but we could have um, other more than one variable. So by definition, so b1 and b0. So adding p of x plus q of x, it's just you add term by term. Okay, so if you have the constants, let's say e0, you will group the constants. So the term of x power 0, then you have e1 plus b1, for example, x, etc. And you continue adding your group your terms. Okay. Here it depends which degree is higher, so you will get okay, so you have, for example, step I, you will have EI plus BI XI, and etc. You continue until you finish all the possible, you include all possible terms. So the difference, for the difference is similar, so you will have minus minus, okay? You make the difference of the coefficients times the variable to the indicated power. So let's practice some questions then. So the first one is what about yes, simplifying the expression, this expression which is 5 times. Okay, so let's write simplify. Okay, so you have 5 times 4x minus 8 minus 3 times 8x minus 8. So here I see that I have a polynomial minus a polynomial. This polynomial degree 1, the second is degree 1. So I will proceed as described here. So I will first or so distribute this factor. So it's 5 times 4, so you will have 20x minus 40. Then here you have minus 3 times 8, 24x, and 3 times 8 minus 24. Okay. Then I have to subtract. So when it's like numbers, the rules of operations are similar. Minus minus plus 24. Then you regroup um, the terms with the same degree. Like here, you have 20 minus 24x, and here you have minus 4 plus 24. Okay. And then here, then you obtain minus 4x, and here 4 from 16 from 10 6, so you'll have 16 by 16. So here is my simplified the resulting polynomial of the difference of those two polynomials. Okay, it's exactly like the like numbers. So let's do one more here. Suppose here asked to we are asked for this example to evaluate a plus b. Okay, so here is the expression a. So I will give it to you. It's a. It's x2. I will write it like that just to prepare something. So x2 minus 6x plus 10. Okay, it's like you will see the analogy with the numbers, how polynomials are behaving like numbers. This one is 3x3, okay, minus 7x2, okay, and then plus x, and then plus 1. So I organize things exactly like that, degree by degree. So way to organize your work. And you make my operation. I want the sum. I want to add those two polynomials. Okay. So the result will be a plus b equal. So I'm adding. So constant with constant, 11, plus minus 6x plus x minus 5x. Okay, x squared minus 6, 7x squared will be minus 6x squared. And here there is no term of degree 3, plus 3x3, so it will be 3x3. And you have your resulting polynomial. Okay. What about now? Sometimes we are given something more so complex in writing, like this one. So let's see how we can do it, so step by step. So sometimes you need to be careful. Okay. So we have 3x2 minus 5x uh, times 5x plus 8 minus then 8 minus 5x2, then plus, okay, plus 8x2 minus x plus 1. So they put bracket here, then they close it these brackets, and then they close it these big brackets. So yes, here you see still we have a difference, but inside also there is a difference of polynomials. There is a sum, etc. So we will work step by step. We can focus is either developing, either doing it simultaneously, either focusing on one step here. Okay. So I think we should work for simplify the expression inside here, then multiply instead of doing everything. Because if I distribute here, I will have more terms, more work to distribute, etc. So let's do it by, so the strategy, it's up to you. Choose the shortest way and the safe, the accurate way also. So let's focus on this term, for example. Let's simplify 8. First step for me, 8 minus 5x2. There isn't only one way to do the work. Just do it correctly. So I see that, yes, adding two polynomials, we said regroup by the degree of terms. Okay, the terms, similar terms with the same degree. So I will regroup the constants, 8 plus 1, okay, then minus x plus minus x, so it's minus x, and then minus 5x2 plus 8x2. So this gives me the expression 9 minus x and plus 3x2. Okay, so the whole, these parentheses now is simplified like that. Let's do now 5x plus 8 minus, so the one we entered, we computed here. So I will just write it, write the resulting here, result, and do the same work here, regroup terms. So the constants, I have 8 minus 9, do slowly, plus 5x minus, and minus x will be plus x, and then minus times plus, so it will be minus 3x2. And finally, I have minus 1 plus 6x and minus 3x2. Okay, so this whole expression is simplified, is, yes, simplified to this one. And now I can go back to P of x and say it's 3x2 minus 5x times the whole expression, which is reduce it to this one, minus 1 plus 6x minus 3x2, and develop and simplify. So I will have 3x2 minus times minus plus 5x. Okay, then minus 5 times 6, it's 30. X times x, I will have a power 2. Then here, mm, plus, minus and minus is plus. 5 times 3, 15. X times x2 is x3. Okay, now I can organize my terms. So we don't have any constant finally. and my resulting. So if I want the highest degree, I can start x3. Degree 2, I have minus 30 plus 3, so it will be minus 27 x2 and plus 5x. And here is my final answer. So you need to be careful with the brackets, the sign before the brackets, the coefficients, distribution operation, etc.